Okay guys, welcome back to class. You're welcome back to class again guys. Now we want to start looking at another aspect in first order differential equation. Guys, understand that we are providing solution for first order differential equation. In the previous video, we looked at provision of solutions to differential equation using direct integration. Now in this video, we are going to be looking at by separating the variable, which happens to be the second method of solving differential equations under first order. Like I explained before, that these methods are used based on the nature of the question. Now, so the question we have will tell us whether we are using direct, separating the variable, homogeneous, linear equation, or binary equation. Guys, how do we know questions that separating the variable method should be used? Now, it is very, very simple. Please pay close attention. Ensure that you do not skip any part of this video if you will be able to get all the secrets that I'll be releasing in this video. Now, let's get started. Now, by separating the variable, the equation is of the form dy over dx is equal to a function of x and a function of y. Hope it's clear, yes. Unlike the direct integration, where we have at the right hand side only a function of x, in this case, at the right hand side we have both function of x and y. But here what matters is how is y related to x? Of course, you know that there are so many mathematical signs that shows relationship between one or two quantities. For instance, addition, subtraction, multiplication, and division. These are the basic four. In this aspect of separation of variables, listen carefully. The relationship between x and y can either be multiplication or division. We have two functions. Now look at it. The first case is the y over the x will be equal to a function of x times a function of y. That means these two functions must multiply themselves. You see now? That means the relationship between x and y should be multiplication, or x should be related to y by multiplication. Then the next method is what? Or the next aspect is what? X, the function of x or the function of y should either be related by division. So any question you have under first order differential equation whereby you can relate x to y by multiplication or by division, such questions are suitable to solve using separating the variables. But understand that when the relationship between them is plus or minus, that is when the next method comes in. So this method is applicable when the relationship between x, function of x, and the function of y is either multiplication or division, any of them, or even both in one question. Of course, yes, you can have both in one question. Now let's get started. Now on the board, we have the very question number 4 on the board, a continuation of our previous class. So if you are new in this, our YouTube channel, please do consider to subscribe to this YouTube channel and ensure you hit on the notification button so that we will always notify you anytime we release mind-blowing content. And ensure that at the end of this video, you like this video and also make your necessary comment, right? Yes, they matter to us. Now listen carefully, we are asked to solve the y over dx is equal to 2x over y plus 1. Somebody say, I'm here. I'm here. I'm following you. I'm following you. Now listen carefully. This is the y over dx, already clear, like we have here. Now at the right hand side we have a function of x and a function of y. Here at the numerator we have a function of x, and at the denominator we have a function of y, right? Which agrees to this. Hope you can see, yes, it agrees to this. So it therefore shows that now that we have function x and y here, we cannot use direct integration method to solve it. Now at this point now we already know that we have x and y. Now what do we check out for? What is the relationship between x and y? Now the relationship between x and y is division, which agrees to this. That means in as much as x and y are related by division, we can simply separate these variables. It's as simple as this. Now, how do we now separate this variable in the solution? We have d1 over dx is equal to 2x over y plus 1. Guys, to separate this variable, all you just need to do is to multiply both sides by now listen, there is a method I want to teach you here, guys. Please, you must pay attention to this method. You see, there are too many ways to do it anyway, but I want to show you the one I think is very, very easy. And this equation is deduced by the wise masters, right? Now I want to show you this approach. Of course, now that we have it here, we want to separate s from y. What do we mean? We mean we should take all s to one side of the equation and all y functions to one side of the equation. And vividly, what we do here is to take all y function to the left and all s function to the right. And for us to be able to do this now, we can simply cross multiply. Y marrying y, x marries to x. It's very simple that way. For this question, but there are other questions where direct multiplication gives you the required answer, except you maneuver it or you take one or two steps. So the easiest way to separate two variables is what I'm quickly going to do now. Now, how do you get it? Identify the functions here that are already rightly positioned and also identify the ones that are wrongly positioned. When you understand this, it will be easy for you to separate variables. Now, let's get started. The y is expected. Now, this is the left hand side, right? Yes. This is the right hand side. At the left hand side, we are supposed to have y. This one is rightly positioned. Now, but this one is wrongly positioned. When we come here, this one is rightly positioned, but this one is wrongly positioned. Guys, I hope you understand what I'm doing here. This is how it is. This is the easiest way to have this done. I want y to come to the left hand side and or x to occupy the right hand side. So what do? Now, this one is expected to be here. This one is expected to be in this side, not here. Now, the next thing we are quickly going to do is, what are we now going to multiply both sides with? Now, I want to multiply both sides with these ones that are wrongly positioned because they are the ones I want to eliminate. This is what I want to quickly do. And how do I get that done? Just all you need to do is to create a fraction. Multiply both sides by. If any of this one that is wrongly positioned is at the numerator, you will change it, you put it at the denominator. But if it is at the denominator, you make it at the numerator. So when we look at this equation that we have here now, we discover that the ones that were wrongly positioned, they are all at the denominator. Are you there? Yes. The ones that are wrongly positioned here, they are all at the denominator. All you just need to do is to make them the numerator. So I'm going to have multiply both sides by what? Y plus 1 dx. This is all over 1 because it's expected to be in fraction. So we are going to eliminate or separate s from 1 when we multiply both sides by the terms that were wrongly positioned. So since the two were at the denominator, you will multiply them together and they will now be at the numerator. So what do? We come here, the left hand side must be multiplied by this. So we are going to have dy over dx times y plus 1 all dx is equal to 2x over y plus 1 times y plus 1 dy over, everything is over 1, everything here is over 1. It's as simple as this. So guys, at this point, the s cancel the s, and at this point, y plus 1 cancels y plus 1, right? Yes. Alright, sorry guys, this is dx. Okay? So now, what is left here, guys? We are going to have y plus 1 dy is equal to, the next one is what? 2x dx. I know you may not be able to get what I'm doing here, but when we move a step further, maybe from question 5, 6, and 7, you'll be able to understand the concept that I'm using here. But if you do not understand this one here, just cross multiply. You will get what I have there. Alright? I'm just using this method for future problems that we are going to solve. This is the easiest way to separate variables. Alright? Now, the next thing we are going to do now, we have successfully separated s from y. Everything here is x, y. Everything here is x, right? Now we can now introduce our integral. So when I introduce integral, I'm going to have y plus 1 dy is equal to integral of 2x dx. Now when you integrate y, with respect to y, you are going to have y raised to power 2 over 2 because you need to increase the power by 1. And when I integrate 1, I'm going to have plus y is equal to, when I integrate 2x, I'm going to have 2x raised to power 2 over 2. Understand, you need to increase the power of the x here, now divided by what? By 2, then plus the constant. At the end, you're going to have y squared over 2 plus y is equal to x squared plus c plus 2 will take care of 2. This is the answer to question number 4. Direct integration. Integrate y, you have this. Integrate 1, you have this. Integrate 2x, you have 2x squared over 2 plus your constant. This is the answer. Now, we'll head on to solving question number. We are asked to solve the y over the x is equal to 1 plus x close bracket, open another bracket, 1 plus y close bracket. Now we put down our solution. Then we have dy over dx is equal to 1 plus x times 1 plus y. Now what do we do here? When we look at this equation very well, we will discover that at the right hand side, we have a mixture of a function of x and a function of y, which shows that we can no longer use direct integration, right? Because we have x here and we have y here. So we have a function of x and a function of y. So this can no longer be solved with direct integration. Check for is what is the relationship between s and y? What's the relationship between the function x and the function y? The relationship between them, guys, as we have it here, is multiplication, because this bracket times this bracket is what we have here. So the first bracket is a function of s, the second bracket is a function of y, and we know that bracket means multiplication. That shows that the relationship between s and y here follows this first method, which shows the y over the x equals to a function of x times a function of y. Now that this is what we have, therefore we can solve this question using separate x from y or y from x. All we do here, guys, is to simply identify the terms that are wrongly positioned and those that are rightly positioned. Now, at the left hand side, we are supposed to have y there, and at the right hand side, we are expected to have x functions there, right? So all the x functions must occupy the right hand side, and all the y functions must occupy the left hand side. Therefore, it shows that this is already rightly positioned because this is the left hand side. This one is rightly positioned because it's a function of s at the right hand side. But this one is wrong. This one is wrong. In fact, every time you are solving problems on separating the variable dx, will always be wrong. Alright? This one is standard. This will always be wrongly positioned. So we must move this. Now, this y function is expected to be at the left hand side, not the right hand side. That is what makes it to be wrong. So what do we do now? We are going to what? Multiply both the left hand side and the right hand side by these functions that are wrong. Now, how do we now get the relationship between this and this? Follow me, guys. We simply say multiply both sides by just create a division. Now, this ds is at the denominator. Put it at the numerator. Now, understand that this is like over 1. This function in its fractional form is over 1. Why 1 plus y is at the numerator? So numerator here will come to denominator. Anytime you are forming a fraction that you will use to separate your function, the one at the denominator from the original fraction will be at the numerator, while the one at the numerator here will be at the denominator. It's just like using the law of inversion. So we are going to have 1 plus y. Numerator comes to denominator, denominator comes to numerator. That's how it is. All we just need to do now, we multiply this, then we are going to have dy over dx times dy dx over 1 plus y is equal to 1 plus x 1 plus y all over 1 times dx over 1 plus y. You finish like this, guys. It's as simple as it is now. Therefore, the s cancel the s. 1 plus y cancels 1 plus y. Automatically at this point, we are going to have over 1 plus y. This is what will be left at the left hand side. Now, at the right hand side, we are going to have 1 plus x times the s. Nothing is at the denominator. So we do not have denominator at the right hand side. But at the left hand side, the y is at the numerator. But the 1 plus y is at the denominator. Then the next thing we do is that now that we have successfully separated s from y or y from s, all we just need to do is to integrate. And before we will integrate this function, we need to introduce our integral, right? So we introduce the integral. We're going to have integral of dy over 1 plus y is equal to integral of 1 plus x dx. At this point, this is a fraction. Understand that anytime you are integrating fraction, you must pay very close attention. Now, this is a fraction. We have a numerator and a denominator. So, anytime you are integrating this function like this, you can decide to further what? Simplify this function as 1 plus y. All the y is equal to integral of what? 1 plus x dx. Now, anytime you are integrating a fraction where you have a numerator and denominator, and in such scenario you now have the variable at the denominator only, this is what you do. Check the power of that variable at the denominator. Is it more than 1 or 1? If it is 1, you are going to have a lane. If it is less than or more than 1, you are going to have another way around. For here, the highest power of y at the denominator here is 1. Therefore, when we integrate 1 over 1 plus y is the same thing as integrating 1 over s, and you know that 1 over s is ln x when we integrate 1 over x. So when we integrate 1 over 1 plus y, we are going to have ln 1 plus y. It's going to be ln of the denominator. When we integrate 1, we are going to have x, and when we integrate x, we are going to have s squared over 2, because the power of s here is 1. Then you add 1 to it, which will now become 2 now. Divide the function by 2. Then plus, it's as simple as this. Guys, this is the answer to question number 5. So very quick, number 7 on the board, and we are asked to solve x dy by dx is equal to y plus xy. So first is to put that solution. Then we have x dy over dx is equal to y plus xy. Like I said, the first thing you must do here is to ensure that the coefficient of dy over dx is 1. And how do we have that done? When we check this one we have there, now we see that the coefficient of dy over dx is what? Is x. Yes, so we are going to divide both sides by x. And when we divide both sides by x, guys, we are going to have dy over dx is equal to y plus xy all over what? X. This is the first thing we do. We divide both sides by x. So we will have already eliminated x from the left hand side. Now the coefficient of dy over dx is 1. This is the first thing you must do. You must ensure that the coefficient of dy over dx is 1 before you take any further step. Now at the right hand side, we will discover that we have a mixture of x and y. In fact, s is even related to y with plus. First of all, we will check whether we can factorize the relationship between s and y that is what connected with addition sign. So now this is y plus xy. That means between these two functions at the numerator, y is constant, and we can factorize out y. Now therefore, we are going to have this as dy over dx is equal to y open bracket y divided by y, we have 1, plus sy divided by y, we are going to have x all over s. Guys, when we multiply this out, guys, we are going to have this back. So finally we can decide to say, okay, this is an extension. The y over dx is equal to 1 plus x over x. Let's arrange it in ascending order. Then outside we put y and the outside there. So we put out y. This is the function of x. This is the function of y. So when we look at this now, the relationship between s and y is multiplication. Right? Yes. The relationship between the function of x, everything inside this bracket now is the function of x, and this is y. So the relationship between everything inside this bracket and this y is multiplication. That makes this question a question to be solved with separation variable. Now, Want to quickly apply the separating the variable technique. How do we do that? First is to identify functions that are wrongly positioned, and second is to identify those that are rightly positioned. Now, like I said earlier, this is always wrongly positioned, and this one is always rightly positioned. Then when we come to the left hand side now, this one is right, but this one is wrong because y is expected to be at the left. So now we have two functions that are wrongly positioned. And understand that this y is at the numerator. So what do? We are going to create a fraction that when we use it to multiply this, we will be able to separate x from y. And how do we create that fraction? We simply come here and say multiply both sides by create a fraction like I do always say. Now, what is the denominator? Among these two functions that are wrongly positioned, the s is at the denominator. So you put it at the numerator. But this y here is at what? The numerator here. Then it's going to serve as at the denominator there in that fraction you are by yourself. So the fraction we are going to formulate, denominator becomes numerator, numerator becomes denominator. That's how you formulate your fraction that you use to eliminate or separate x from y. Now we are going to have this as y. So this is what we are multiplying both sides. Now when we multiply both sides by what we have there, we are successfully going to separate x from y totally. Now we are going to have this as dy over dx times dx over y is equal to 1 plus x over x times y times dx over y. So y takes care of y and the s takes care of dx. So at this point here we are going to have 1 over y dy is equal to what? 1 plus x over x dx. So when you look at this now, we have successfully separated x from y or y from x. All we just need to do here is to introduce our integral so that we can integrate, because like I told us before, in first order differential equation, before you can get your final answer, you must integrate, and you only integrate when you have successfully separated x from y. Now we can integrate. So we introduce our integral 1 over y dy is equal to 1 plus x over x. Now, at this point, you see that this is a fraction, numerator. You have two terms at the numerator and one term at the denominator. You must separate the fraction. So we are going to have 1 over the denominator x plus x over x. Is a must that anytime you have multiple terms at the numerator and you have only one term at the denominator and you want to integrate that function, you must ensure that you share the denominator for the numbers of numerators that you are given. Now we have two functions at the numerator, 1 and x. So you are going to have 1 over x plus, which is this plus and x over x, or dx. Then we introduce our integral. Finally, we are going to have this 1 over y dy is equal to integral of 1 over x plus x divided by x, we have 1, or dx. Next 1 over y, I'm going to have ln y is equal to, when I integrate 1 over x, I'm going to have ln x. And when I integrate 1, I'm going to have plus x plus c. Now I have ln at the left hand side and I also have ln at the right hand side. I can decide to what? Bring all the functions with ln together. And if I do that, I'm going to have ln y minus. Now when ln x crosses the sign of the quality, we are going to have ln x is equal to x plus c. Now, ln y and ln s have something in common, and you remember in long grading that if you have ln a base b plus ln c base b, and you also have ln a base b minus ln c base b, that this is equivalent to what? Ln b into a over c. So when you have minus in between two ln, the function, you find the division, you find what? You divide the first function by the second function. So in this case now, in as much as we have ln y over ln x, we are going to have ln y over s using the long grading rule, because ln and long grading, they are the same. Then, which is equivalent to x plus c. This is our answer. For some of us in another school, it's either you use ln x or long exponential ex. These terms are the same. So you can be using this or this depending on your course lecturer or your school system. There are some schools they use link, there are others they use log x based exponential. They are all the same. So either you use this or this, but here in these tutorials we are using the question number 7, right? Now, question number 7, we are asked to solve the y over the x is equal to y squared plus xy squared all over x squared y minus x squared. Now, something is common and special about this question, right? Now, let's put down our solution as we begin to solve this step by step. The y over the x is equal to now, guys, at this point, all we simply need to do is first, we have already seen that the y over the x has a coefficient of 1, not to be done here, but here, when we come here, we see that x and y, they are mixed up together, right? Can you see here? X and y, they are mixed up together. So we first of all look out for a way to separate x from y. Let's first of all see if we can factorize out x from y or y from x. Based on the arrangement that we have at the numerator, we have y squared plus xy squared. That means y squared is common at the numerator. Then when we come to the denominator, we have x squared y minus x squared. That means at the denominator, x squared is common. Then we can factorize this. How do we do that? We have the y over the x is equal to y squared into, when we remove y squared from here, we're going to have 1 plus x. Then all over, at the denominator, x is common, we have x squared, open bracket, y minus 1. So guys, this is it. This is it. Then the next thing we do now is to now ascertain this, whether the relationship between x and y here is multiplication. Now let's separate it. Let's take a step further. The y over the x will be equal to 1 plus x over x squared. Let's arrange all x to one side and y to one side. So I take the numerator of x and the denominator of x, I put it in one bracket. Then y squared over y minus 1. Guys, if I multiply this, I will get back this question. Or first I'll get this, then get this. Right? Now at this point, the relationship between x function and y function here is multiplication. And how do we do it? What next do we do? We now know that we are going to separate the variables, in as much as the relationship between x and y here has been deduced to be what? Multiplication and division. Now we have a multiplication. So what do? We separate x from y or y from x. Now how do we separate x from y? We simply say multiply. Now we simply say here multiply both sides by create a fraction. We want to generate a fraction such that when we use that fraction to multiply this equation, we will be able to separate x from y. You know, like I said when we started earlier on, if you could remember, I mentioned that there are some cases whereby the direct cross multiplication will give you the answer. But in some cases, direct multiplication will not give you the answer, except after you have already cross multiplied, you now still won't go ahead, divide both sides, just like that. But the easiest way to separate x from y in one step is what I'm just teaching you now. So if you have not paid attention to this method since we started this, because you know that direct multiplication or direct cross multiplication will do it, please, you need to pay attention here now, because this method will help you, most especially in meeting up with time when you are writing some of these exams, because they can be time consuming if you do not know how to cut off some things very well, right? So at this point now, if I say, okay, let me cross multiply, it's going to take me a long process before I'll be able to separate x from y, because it's not direct, it's mixed. But the easiest way is what I want to teach you now. First is to create a fraction. I want to formulate a fraction such that if I use to multiply this, I'll be able to eliminate x from y. Now, guys, what are we going to do now? We said that this is rightly positioned, but this will always be a wrongly positioned function, right? Which is the x. But at the right hand side now, x is rightly positioned, but y is wrongly positioned. So what am I going to do? It therefore shows that I am going to one that is wrongly positioned. Now, the next thing I do to formulate this fraction is anyone here that is wrongly positioned, that is at the denominator, I will put them at the numerator of my fraction. Are we there? I want to generate a fraction. So this fraction I want to generate, the numerator will be the denominators here. Now the x is a denominator, and y plus 1 is also at the denominator. So I'm going to have y minus 1 is at the denominator, and the x is at the denominator. So anything at the denominator here will form my numerator here, and anything wrong here at the numerator will form my denominator. Now at this point now, it is only y squared that is wrongly positioned, which is at the numerator. Here it will now be at the denominator. I hope you understand this logic. If you understand this, guys, it's as simple as this. All we don't need to do is to multiply this equation by this. You are going to successfully eliminate x from y, which is dy over dx times y minus 1 dx all over y squared is equal to 1 plus x over x into y squared over y minus 1 times y minus 1 dx over y squared. This is the statement that we just made here. That's what we have just put into use. Now the next thing we are quickly going to do, guys, is to cancel out. So this, we take care of this, and guys, we are going to be having d square y into y minus 1 over y squared is equal to, now at the right hand side, this will take care of this, guys, and this we also take care of this. So what do we have left? At the right hand side, we are going to have 1 plus x over x all dx. It's as simple as this. Then very quickly, the next thing we are going to do is to introduce our integral. It's as simple as that. We want to integrate because we have successfully separated x from y. So we introduce our integral and arrange this as y minus 1. Now guys, y minus 1 over y squared dy is equal to integral of 1 plus x over x dx. Now, the next thing we are quickly going to do here, guys, is to look at this function very well. Now, these functions we are about to integrate, they are all in fraction. And I said, when you have a function in fraction and you want to integrate it, you must check whether you have a simple denominator to that fraction. Yes. In this case now, we have two functions at the numerator, but one denominator. We are going to separate the fraction. So here, we are going to have integral of y over y squared minus 1 over y squared all dy. Then equal to integral of, here also we have two functions at the numerator to one denominator. We are still going to split the fraction. We're going to have 1 over the denominator plus x over the denominator all dx. Then the next we are going to do, guys, is to cancel out the ones that we cancel. Then this will give us integral of 1 over y. Understand that y divided by y squared, 1y will take care of 1y here. Then at this point, we are going to have minus y raised to power minus 2. I have explained this over and over again that anytime the power of the variable at the denominator is more than 1, just change it to what? A direct fraction. But when it is 1, like this case, I say I didn't change this case, you know that the answer is going to be in linear. But once the power is greater than 1, convert to a linear function. Alright? You may not convert. Maybe I will explain how to integrate this without conversion. Alright? Then this will be equal to integral of 1 over x plus 1. Understand that x divided by x is 1. Okay, now the next thing we are quickly going to do, guys, is when we integrate 1 over y, we are going to have in y minus, when we integrate this, guys, we are going to have minus 2 Now listen guys, understand that when you have a variable that has a power and you integrate it, you definitely add 1 to the power. So if I have minus 2 existing as my power, then I add 1 to it, I'm going to have minus 1. So this will have been minus 1 divided by what? Minus 1, because that's new power. Minus 1 is a new power, alright? Then equal to, when I integrate 1 over x, I'm going to have in x, and when I integrate 1, I'm going to have x plus c. It's as simple as this now. Minus y raised to the power 1 divided by minus. Now, minus divided by minus, we are going to have ln f y plus y raised to the power minus 1 is equal to ln x plus c. Finally, guys, I'm going to have ln y. Now, plus understand that you cannot leave your answer having a negative power. So you need to also convert it back to fraction. Then we are going to have 1 over y is equal to ln x plus c. This is the answer to this very question. So you see guys, it's a bit lengthy, but I guess it's very understandable. It's as simple as this. When you know the rules, you suddenly become a master. Now look at something here. I want to quickly explain this concept that you can integrate like this without changing it to linear equation. Alright? But I don't want to be using shortcut. Now let me do it so that in other subsequent video, we are going to be using this method. Now, if I have integral of minus 1 over y squared dy, this is what I want to integrate, guys. All I just need to do, listen carefully, is to have minus 1 over. Now, reduce this power by 1. It's going to be this. Then multiply this sign by minus 1, turn plus. I don't know if you understand this. Okay? You see now, let me explain again. This is what we have. The first thing you do is to multiply. Now, I want to integrate this. I have minus 1 over y squared. I want to integrate this, guys. The first thing you do is to multiply this function by minus 1. If you don't want to combine it. So if I multiply this by minus 1, I'm going to have plus. Now the numerator becomes 1 all over. Reduce this power by 1. I'm going to have 2 minus 1. I'm going to have plus 1 over y raised to the power 1. It's as simple as this. Now guys, what happens if the power here is 3 or something more than, maybe here is 4? It's the same thing you do. Same thing. All you simply do here is, first, is to multiply this sign by minus 1. And when we multiply this by minus 1, we are going to have plus 1 at the numerator. Simple as this. Then the next thing you do is, please pay attention to this. The next thing you do here is to reduce this by 1. This will have given us 3. It will give us 3. Then also, this 3 will also be here. You now multiply the denominator as well by the new power. It's as simple as this. It's as simple as this. Alright? So, first is to multiply by minus 1. It will turn into plus. If it was positive before, it turns to minus. Then also reduce this by 1. Whatever new power you have, use it to multiply the denominator, so it will also serve as the coefficient. It's as simple as that. Then also, if this is 2 for it's 3 now, to differentiate, to integrate this, multiply this by minus 1, I'm going to have plus 1 over, reduce this by 1, I'm going to have y raised to power 2, then these 2, take it as the coefficient of the denominator. This is how to integrate this without first converting it to linear. Now, if I converted this to linear, I'm going to have minus 3. Then if I integrate, I'm going to have y raised to power minus 2 over minus 2. So minus affects whatever sign that is here before, it becomes plus, it is there. 1 over 2y squared. This is all about this aspect of integration. So guys, see you in question number 8. Now on the board, we are asked to solve cos square x dy over dx is equal to y plus 3. Now this is our solution. We have cos square x dy over dx is equal to y plus 3. Now guys, what do we do here? The first thing we do here is to make that happen, we must divide both sides by cos square x. Then we are going to have dy over dx is equal to y plus 3 all over cos square x. Now, we can decide to put the numerator in bracket, showing that here the numerator is a function of y and the denominator is a function of x. Now, the relationship between x and y is what? A division, right? So yes, the relationship between x and y is division. Then what do, guys? We are going to separate these two variables. And how do we separate them? We are quickly going to multiply both sides by a fraction that we will formulate. And how do we formulate this fraction? This is good, this is bad. I don't have much explanation to this, right? Then this is bad, this is good. How? At the left hand side, you have only y there. Now at the right hand side, you are supposed to have x there. So anytime you see y at the right hand side, that means it's wrongly positioned. And anytime you see x at the left hand side, that shows that x is wrongly positioned. That is what makes this to be wrongly positioned, because this is the left hand side. So x is not supposed to be here. And this is the right hand side. Y is not supposed to be here. So these are the reasons why this portion and this portion are the ones that we marked bad. So what do we do next? We need to now formulate our fraction. How do we formulate our fraction now? Those portions we consider to be wrongly positioned, we want to position them to form our fraction. The one at the denominator here, any one at the denominator will form a numerator here. And any one at the numerator will now become the denominator. So this is how you arrange your fraction to eliminate or separate x from y. Now that we have gotten the concept of this, then we can proceed. So we simply multiply dy over dx by dx over y plus 3. This is the left hand side. At the right hand side, I have y plus 3 over cos square x times dx over y plus 3. Guys, this takes care of this. This takes care of this. It's as simple as that. So now, at this side, we are going to have dy over y plus 3 is equal to dx over cos square x. Now that we have successfully separated x from y, guys, we need to introduce our integral, right? Now let's quickly introduce the integral. By introducing the integral, we are going to have integral of 1 over y plus 3 all dy is equal to integral of 1 over cos square x dx. Now, in trig identity, generally in integration, there is no way you can integrate 1 over cos square x. So you need to find 1 over cos square x to another trig and replace this that we can easily integrate. And what is that identity? Now understand that 1 over cos x is the same thing as sec x. Now we're going to recall that 1 over cos x is equal to sec x. Therefore, 1 over cos square x is equal to sec square x. It's as simple as this. This is trig identity we just employ now. Why? Because we cannot integrate 1 over cos x directly. Alright? So we need to find another trig identity that we can easily integrate. And that's the reason why we have to sort ourselves out this way. Now at this point, we are going to replace this by sec square x. We are going to have integral of 1 over y plus 3 dy is equal to integral of sec square x dx. So we just replace this by this. Now, the next thing we do is to quickly integrate this function out. At this point, we see that at the numerator we have one term and the denominator we have two terms. We cannot split this fraction. All we just need to do is to identify the power of the variable at the denominator, and that power is 1. That means if we integrate this, now we are going to have ln of the denominator because the power of the variable is 1. But if it is more than 1, you will have to find another way around. Right? Yes. So when we integrate 1 over y plus 3, we are going to have ln y plus 3. Now when we integrate sec square x, guys, we are going to have tan x. plus constant. This is the answer to this question. You don't need to stress yourself. It's as simple as this. Very simple. Principles, principles, principles are the things that you should seek to know anytime you are looking at any aspect in mathematics or generally in calculation courses. When you know the boundary conditions, you will not overstep your boundary. Understand that? When you know the boundary conditions, you will not overstep your boundary. Let this sink into your brain. This is the Master Builders Academy where we impart your mental capacity, because we call this a call to a mental and academic revolution. Now we have come to revolutionize the academic cycle of this nation and the world at large. So guys, if you have not subscribed to this YouTube channel, ensure you do so. Hit the notification bell so that anytime we upload mind-blowing content, you will be notified. And as well, ensure before you leave or exit this video, like this video and share this video. In fact, make question number 9 on the board. Get started. Now we are asked to solve sine x over 1 plus y dy over dx is equal to cos x. This is what we are asked to solve, right? Now this is solution. We have sine x dy over 1 plus y dx is equal to cos x. So as usual, we can also decide to make the coefficient of x dy over dx. We can also decide to make the coefficient of dy over dx 1 or make it solid of formula. But now, when we look at the coefficient of dy over dx, it's a fraction. Right? Yes, listen carefully, because there are so many ways we can solve. We can still use that same method, but I want us to use a simpler method here. So we see that in this case, it is only x that is wrongly positioned. All the y functions, they are already at the left hand side. But there are some x functions that are at the left hand side. They are supposed to be at the right hand side. So you see now, no function of y is wrongly positioned. So there is no need of us trying to rearrange this and make y functions to be wrongly positioned. So let's just go straight and what? Make x appear at the right hand side where it should appear. Now, what do? We identify that this is wrongly positioned and this is wrongly positioned. So we simply say multiply both sides by your fraction. Now these two functions are wrongly positioned. The denominator here will become your numerator, and the numerator here becomes your denominator. It's as simple as that. Denominator becomes numerator in the equation you are formulating, then numerator becomes denominator here. It's as simple as that. So what we need to do now is to multiply this function by this multiplicating factor we just generated. All we need to do is to have sine x over 1 plus y dot dy over dx times dx over sine x. Well, you can decide to use bracket if you choose to, then equal to cos x times dx over sine x. We just multiply both sides by this. Then the next thing we do is to cancel out this guy, we take care of this guy, and this guy, we take care of this guy. And what we are left with now is 1 plus 1y or dy is equal to cos x over sine x dx. I decide to put this also in bracket. This is what we have, guys. Now we have separated x from y. What is the next thing, guys? Now the next thing we are quickly going to do is to introduce our integral. We will have 1 over 1 plus y or dy is equal to integral of cos x over sine x or dx. Integration by substitution method, whereby you take the denominator as another letter entirely. So what we are going to do now, because of the right hand side, we are quickly going to do a little mathematics before we bring in our integral. Simply say, let u be equal to, now we want to use substitution method. Please listen carefully. I want to deal with the right hand side. I want to use this because this is not something we can easily get the answer. I can give you the answer very shortly, but there is a way to have this done, which is expected of you. Now listen carefully. So it's going to take us time. Now let me work it out somewhere. We simply say let the denominator here be equal to what? Any other variable. So we simply say let u be equal to sine x. Now when we differentiate u, the u with respect to x, because this function is a function of u and x, we are going to have sine cos x. Now listen guys, what do I really need substitution method for? We majorly use substitution method in integration anytime we feel that when we differentiate the denominator, it will give us the numerator. This is where substitutional method is used. That when you differentiate the denominator, it will give you the numerator. So when we differentiate sine now, it's going to give us cos, right? This is the reason why we want to use substitution method, so that we will be able to integrate this function. Otherwise, this will be a problem. Now let's go. Okay, now let's go. So what do? Here we are going to make ds the subject of the formula. After differentiating u with respect to x, we are going to have du dx is equal to take this down and take this up. So when we cross multiply, this will come under du and this will be the subject of formula. So we are going to have du over cos x. Guys, all we now need to do now is to come to this expression and begin to substitute. Now we have integral of 1 over 1 plus y all dy is equal to integral of, the numerator is cos x. Now the denominator, we have replaced this denominator by a letter called u, right? So we put that in here. Times also substitution method. And guys, what do you actually do in substitution method? One of the two things you do in substitution method is to replace the denominator by another variable and substitute for the s. So these are the two things that it affects. So first now, we will substitute for sine x, which is the letter we use to represent sine x, and also remove the s from here. And that's the reason why we differentiated that function we have. Now, in place of the x now, I'm going to have du over cos x. Guys, this will take care of this. And finally, we are going to have integral of 1 over 1 plus y all dy is equal to integral of 1 over u du. You see, this is where we are. Now, at this point, all we simply do, guys, is to integrate. Now, at the denominator, I have a function of y here. This is a fraction. Like I do always say, you need to pay attention to integration of fractions. Now I am integrating a fraction. Now, where is the variable at the denominator? What is the power of the variable? 1. Then my answer will become ln of the denominator. And I'm going to have ln 1 plus y is equal to, when I integrate 1 over u, I'm going to have ln u plus c, which is my constant. Now the next thing I'm quickly going to do here is that from the question, my question came with two variables, x and y, and my answer will also be in terms of those variables plus constant, which is this. So u was never If you find this content helpful, don't forget to hit the subscription button, turn on the notification bell so that you will be notified anytime we release mind blowing content. And before you exit this video, please make your necessary comment and like this current video. You just love you. Thank you for watching. See you in the next video.